was somebody that we worked for our own independent company. If we work for the government, we make this thing ridiculously impossibly big so that way we can get spending for the next year. That's what we really do, okay? But if I owned my own company and I wanted to make a better, more efficient, cheaper circuit with less of these logic gates, I would use my Boolean rules to simplify it, okay? Isn't it much cheaper for me to have a circuit instead of having all this crap? Instead of having all that crap, wouldn't it just be easier for me to have this? Those two circuits are exactly the same. Don't need a Q. Don't even care what Q is. Somebody could be firing a Q into the computer, just let it do whatever it wants in the computer. Just have a resistor in there, okay? So it eats up the impedance, okay? Doesn't matter. So this is why Boolean algebra can be used in real life, okay? Now, obviously, most circuits are much, much more complex than this, okay? That's why they hire teams of people to do this algorithm analysis.
Is that not inside the triangle?
Oh yeah, anytime you have a triangle, it's a not, no matter what, okay? So if you have like this guy, it's an and. So I know it looks like crap, sorry, this stupid marker, okay? Actually, it's my handwriting, I can't even blame the marker. Okay. Does that make sense, guys, as to how to build a Boolean circuit? You just start from left to right and you just go for it, okay? Let's do the second one together, just to make sure we're on the same page with this. Okay, so I'm gonna erase all my crap here. Or at least I'm gonna try to. Come on, magic marker. Let's go. There we go. Okay. So if I was to build, now I need a real eraser. If I was to try to build a Boolean circuit from this, okay, or a Boolean expression from this circuit, the first thing I do is I see a P or a Q. Okay, so I see P or a Q. Put that in parentheses. Okay. I also see, the next thing I see is a P and a Q. So what I'm going to do off to the side of that is I'm going to have a P and a Q, and I'm going to put that in parentheses. Okay. And then there's a couple more things I need from this. So what's the next thing I might do to build this circuit or build this expression?
A not.
I need a not in front of this one, right, sir? Very nice. Because guys, doesn't it say once it goes through the and, I negate it? So this is going to be a not right here. Okay. And then finally, guys, I need one more thing to finish this off. Yeah, we need an and, right? Look at the very last thing that we have on the right. That's an and. So I'm just going to run an and through this. Okay. This is an example of a circuit that we can't really do anything to simplify. Okay. I know what some of you guys are thinking. Let's use De Morgan's law and just go ahead and do a double not. Okay. So we can go ahead and write this as P or Q and not P or not Q. But once you get there, you can't do anything with that, okay? Because you can't really factor out a P because these aren't the same, and you can't factor out a Q because the Q's aren't the same. There's actually 4 unique different statements going on here. In fact, if you guys were trying to build the cheapest circuit, which one would be cheaper? The one without De Morgan's law or the one with De Morgan's law? Without, right? Because doesn't this one need 2 nots, and this one only needs 1, okay? So, sometimes the Boolean algebra is good. In this instance, it's not so good. But at least we tried, okay? So, no harm done. So this is the best circuit that we can get out of this, okay? When I give you guys these problems on the homework, I just ask for a circuit. I'm not asking you for the best circuit, okay? Your next teacher might ask you for the best circuit. That's when you use the Boolean rules. Okay. Questions I can answer, guys. Pretty easy stuff. Yes, sir, please.
So distribution wouldn't work at all because of the not.
Correct, right. If for some reason I did this, which would turn into that, then you could factor out the P, okay? But it doesn't do that, unfortunately. So we're stuck with that ugly beast, okay? All right, other questions, guys, I can answer. Okay, nice and easy. I usually put something like this on the exam for 5 points, okay? So those would be 5 easy points for you guys. Okay. We haven't necessarily looked at the table and trying to get some sort of circuit from the table. Okay, so let's take a look at an example of that. So I have 2 different tables, and what I want to do is I want to construct, excuse me, I want to construct a Boolean circuit from the table. Okay. Now, I know what some of you guys are going to do. You're just going to bully it out, and you're going to figure out what permutation works, right? And that's fine for the first one. Might even be fine for the second one. But what happens when we get circuits that literally have like maybe 5 inputs? Oh, it ain't going to work anymore, right? There's only so far and so smart we can be, okay? Here's the way to approach it, guys. If it has an output of 0, don't care. Okay? So, whenever you guys are doing these problems with input-output tables, okay, why do I want an output of 0? Well, I'm not going to be able to construct something that has an output of 0. I'm going to, by default, get something that has a 0. What I'm going to focus on is I'm going to focus on the rows that have an output of 1. Okay? In computer programming or computer architecture, we call that a recognizer. Okay? So any column that has a 1, okay, that animal is called a recognizer. We don't care about the other rows. Okay? Like I said, this is not the most efficient circuit. Okay? So what somebody does is they make a circuit from what they have here, and then they might use some Boolean algebra to simplify it. Okay? So let's actually make the circuit. Okay? Notice I have 2 inputs. I have a P and a Q. Okay, actually, let me do this on the board, because it'll be ugly if I try. You guys can fit it in here, because you have a nice little pencil and pens. So I have a P and a Q. Notice the first input that has a recognizer. P is true and Q is false. So here's what I'm going to do. P is true, and I want Q to be false. So basically, if it has a 0, I'm just going to affix a knot to that. Okay? And think about it, guys. If I throw 1 0 through this, 1 0, that's going to end up being true, provided that these two are connected with what digital logic's circuit? Not an OR, but an AND, right? They have to both be true. Okay, so I'm going to connect these with an AND. Does that make sense, guys? And that's just for the first of the 2 rows.
Okay, Q is 0. Okay.
Correct. See how we have 1 0, and all we're doing is just throwing the 1 0.
Yeah.
Now, let's focus on the second row of the recognizer. Okay? All I'm going to do is I'm going to branch off of this. So here's my P. Here's my Q. Okay. Notice that both P and Q are zeros. So there's 2 different ways I could build this. Okay? One way is I could just put a knot on both of these. And then connect those with an AND. Okay, and that's perfectly fine. There's nothing wrong with that. Okay. Another way to do it, or maybe you guys can tell me, what's another way to be able to do that? Couldn't you just connect it with a big old knot? Okay, just like a huge knot would work too. Okay? But if we're just going through and trying to create a circuit, not the most efficient circuit, we would just put a knot on both of those.
I mean, a knot only takes 1 input, right? So wouldn't you have to put an AND and then a single knot?
Well, when you do a knot implies AND as well. Okay, it's almost like a NAND, if you do that. So a knot AND.
Oh, when you have 2 inputs into a knot.
Right. If you do this, okay, you can assume that's a NAND circuit, if you would, not AND. Okay. So, but this is probably just more clear if we do it this way. Now there's one more thing that we have to do to finish this circuit off. Okay? Does anybody think they might know the last thing we have to do to finish this off and make it a correct circuit? Well, remember, digital logic circuits only have 1 output. This has 2 outputs right now. So we have to somehow connect these. We're going to connect it with, what was it, guys? An OR, correct? How come an OR, not an AND? Well, remember, as long as row 2 or row 4 is valid, you want an output. Okay, so when you guys are done, what you guys are going to do is connect it with an OR statement. Okay. If you wanted the most efficient circuit, what you guys might do is just construct a Boolean algebra expression for this, and then try to use the Boolean laws to simplify. Okay, I'm not asking you guys to do that. I'm just saying if you were to do that. Does this make sense, guys? Any questions? Not meant to be difficult. Sir?
You could just do not Q, couldn't you?
Yeah, this, in fact, if you were to express the Boolean, it would exactly work out to be not Q. Because what you notice is that the Q's are 0. Anytime the Q's are 0, the output's 1. In fact, if anybody wants to go through and verify that, you probably have to use De Morgan's law, then you have to use the distributive law, and then probably an absorption law to verify. So did you just inspect that and know,
Yeah.
because you're just like, oh, that's easy to see? Yeah, and that's fine. If you can see it, that's great, okay? Like I said, with 2 inputs, most of you guys could probably bully it, okay? But like I said, if I start having 3, 4, 5 inputs, you're not gonna bully it, it's gonna bully you if you do that. Okay, so other questions or comments so far? Okay, why don't you guys try the second
Why
one?
did you add the or again at the end? Can you,
Why is there an or at the end?
Mhm.
Remember, this is a recognizer. We want the output to be 1 if this is valid or this row is valid. It doesn't matter which row is valid. It just matters that one of the 2 rows is valid. Okay? But why don't you do this? Why don't you run 1, 0 through, okay, and you'll see that it works. Run 0, 0 through, and you'll see that it works. Okay? But remember, you got to connect it with something. Okay? And if you did it with an and, well, there's no way to have these both true at the same time. It doesn't work. Okay? It's either one's true or the other one's false. Okay? It might be helpful, like I said, to run both of these through the circuit to justify to yourself that it works. Okay? So give that a try and see if that works. Okay? Alright guys, so go ahead and see if you guys can do the second example. Okay, I'll give you guys a few minutes to do it. It might look like an ugly circuit. That's okay. Do what you can with it. If anybody needs help, let me know so I can come over now.
Yeah, I'm not sure how to think about this.
Okay, so maybe the first thing you want to do is get rid of anything with an output of 0, right? So that way you're only focusing on rows that have an output of 1. So these are going to be the only 3 rows that you're worried about, right? There's 3 inputs, P, Q, and R. So, start with the P, start with the Q, and start with an R. And then from there, what you might want to do is just use the example we looked at before. If that has a 0 in that column or in that row, you just put a not gate on that. Okay? And you're going to have, I believe you're going to have 3 different, I'm going to call them like subsections of this, if you will, because there's 3 recognizers. Does that make sense, sir?
No, you are doing 2 operations on one of this logic, right? Like with AND, you're doing 2 operations.
Yes.
P and
And you only need one and
okay.
to connect all 3 of them together. Because it could be P and Q and R at the same time.
Got
Okay?
it.
If you wanted to, you could make it 2, but you really only need 1. Oh, for those of you guys that are done, I don't know if there's a more simple circuit for this. There may or may not be, but if it is, it might be tough to find it.
inputs to go into an AND or?
You can do 3 for this, okay, just do like a theoretical. You don't have to do like P and Q, and then another one that stems from it, okay, so you can do more than that, okay? Because remember, we're just throwing it into like I guess the logic component that makes it up, so, yeah.
How much would you actually be able to do in like a real situation?
In a real situation, you'd actually have to do, if you're talking bare bones, you have to do P and Q first,
And then,
then the output of that, you'd link it up to an
and then
AND.
R?
Yeah, but we're lazy, we'll just do 3 at a time. Or we're efficient, I'm sorry, that's the government word for lazy.
Appropriately.
Yeah, appropriately lazy, indeed. Done.
For the second one, I'm doing the 0, 1, 1, 1.
Mhm.
I have or connecting the P and the Q. How do I add this then?
Now, you shouldn't have an or until the very end. Everything should be an and until you get to the end of it.
Okay, but still, I'll have one left over, so I could add the one, right?
At the very end, you should have the or, but you shouldn't have ors in between there anywhere. So, you might want to use a not instead. Alright, let me go through and show you guys like what I would do if I was constructing this circuit, okay? Obviously, there's 3 inputs. If there's 3 inputs, you should have 3 wires, if you would, running through those, okay? I look at the first line. P, Q, and R must be true. So what I'm going to do is I'm going to say P is true, Q is true, and R is true, and just connect those all with a big old and, okay? Technically, okay, and this is what the gentleman asked, what it should be, okay, is that we should have an and running through the PQ and then connect it with another and. I'm not worried about that, guys, okay, so just do it all at one time. Does that make sense, guys, as to why that's going to be an and? It's because all 3 of the first line is true. For the second line, okay, now notice that the P is false. So what I'm going to do